Questions from released PARCC examination. All right, the circle with center F is divided into sectors. In circle F, EB is a diameter. The radius of circle F is 3 units. Drag and drop each arc length to its subtended central angle. All right, so here we have angle AFB. So this angle here, which has a measure of 120 degrees. We have 120 over 360 times 2 pi r. So 2 times pi times r, which is 3. So when you solve this, you get 2 pi. So we'll drag 2 pi right there. All right, next we have angle BFC. BFC is this 45-degree angle there. So 45 over 360 times 2 times pi times 3, which is 3 pi over 4. So we'll drag that over right there. All right, next we have angle CFD, 30 degrees. So 30 over 360 times 6 pi, which is 2 times 3, pi equals pi over 2. So I will drag this pi over 2 right there. And then finally, we have angle AFE, this angle here. Well, to figure out what this angle is, remember EB is a diameter, and this angle here is 120. So this angle plus this angle equals 180, making this angle 60, since these are supplementary angles. So we have 60 over 360 times 6 pi gives us pi. So we'll drag pi over, and there we go. The figure shows triangle ABC inscribed in circle D. If the measure of angle CBD here equals 44 degrees, find the measure of angle BAC. So find this angle here. All right, well, we know this is an isosceles triangle since these are both radii, so they're congruent sides, creating an isosceles triangle with this as the base. Therefore, the base angles are equal, so they're both 44. Now, because of the triangle sum theorem, we know that all 3 of the angles in here add up to 180. So 180 minus 44 gives us 92 degrees here. That makes the arc here 92 degrees because this is a central angle. This is an inscribed angle, which is half of the intercepted arc, so this is going to be 46 degrees right in there. 46. The figure shows a circle with center P, a diameter BD, and inscribed triangle BCD. PC equals 10. Let the measure of angle CBD here equal x degrees, and the measure of angle BCD equal x plus 54 degrees. Find the value of x. All right, well, I wrote x and 54 in these spots on purpose because since this side and this side are both radii, that means this is an isosceles triangle with a base angle of x, which means the other base angle is also x, which makes this angle here 54 degrees since this is a right angle. Whenever you have a triangle where the hypotenuse is a diameter, it is a right triangle. So that makes this 54 degrees. This whole thing is 90 degrees, so 90 minus 54 gives us an x value here of 36 degrees. Part B, the length of CD. All right, well, let's figure out what this angle is here. So this angle right here is an exterior angle for this triangle here. So that would mean that this angle is this angle here plus this angle, so 2x. What is x? 36. That makes this angle 72 degrees. So the length of CD is going to be greater than 10 because 10 is the radii, but this length is going to be longer than a radius because this angle is greater than 60 degrees. Point B is the center of a circle and AC is the diameter of the circle. Point D is a point on the circle different from A and C. All right, so we have a circle here. We'll draw a diameter here, and we will label the points. So this is A, the center is B, and this is C, and we have point D as a point on the circle different from A and C. So let's put D over here for now. Drag and drop the following choices into the boxes to indicate which statements are always true, sometimes true, or never true. All right, AD is greater than CD. So AD is this line there. CD is this line here. Well, that's true here, but if D was over here, that would not be true. So the first one is sometimes true. All right, moving on. The measure of angle CBD, so draw this radius here. So this angle equals 1/2 of the measure of CAD. That is not true. This angle is twice the size of this angle, not half. So this one is never true. All right, moving on. The measure of angle CBD equals 90 degrees. That is sometimes true. So if D was like right here, up here, then this would be a 90-degree angle. So that is sometimes true. And then finally, the measure of angle ABD, so this angle here, equals 2 times the measure of angle CBD. CBD is here. So I guess sometimes, like if D was here, and that might be 2 times the measure of this one, but if D was over here, that would not be true. So this one is also sometimes true. Part B, if the measure of angle BDA, so this angle here, equals 20 degrees, what is the measure of angle CBD, which is here? All right, so I copied and pasted the drawing from the previous slide into this problem so that we have a visual. All right, so if this is 20, well, what do we have here? We have an isosceles triangle here. Since this side and this side are both radii, that means they're congruent. So here's the base of our isosceles triangle. 20 degrees is a base angle, so this other angle here is also 20 degrees. Now this angle, CBD, is an exterior angle for this triangle here, meaning that the measure of this angle we'll call X is 20 plus 20. So this measure is 40 degrees. The answer is B. The following question from the released PARCC exam uses what we just learned and combines it with what we learned earlier to create a challenging question. Please try it on your own. Then we'll go through the process we used to solve it. The figure shows 2 semicircles with centers P and M. The semicircles are tangent to each other at point B, and DE is tangent to both semicircles at F and E. If PB equals BC equals 6, so 6 and 6, what is ED? All right, well, the answer to this question is the square root of 72, but we will take the next several slides to explain how we figure that out.